So I didn't get anything done again this week other than thinking about things. I was thinking I did something. I was thinking about the robot, but I can't remember what it was. So I guess I don't have anything to report. So we'll just turn it over to Al.
Couple things to mention. Jeff enlightened me about publishing an array of values that here to date had been just sort of internal variables. So did a little bit of that, which helped. Bob had shown us a little bit of his whiteboard tool. I think he's mentioned it a number of times, but I spent a little bit more time on his, and I had been previously using an Apple product, and I'll show my board here in just a second. But I mean, thank you, Bob, in case you watch this. I really found that Miro product useful and helpful, especially to be able to share the whiteboard, because the Apple product was really Apple centric and wasn't very easy to share that.
Just to comment on that, that Miro, you can actually share that in real time. So if somebody goes in there, if somebody's playing around with your whiteboard, you can actually watch them doing it on your screen. So it's interactive both ways, which is it's a handy thing if that's what you want to be able to do.
Yeah. And then did a couple of test drives in the yard, and there were some issues that I'm still working through, namely, well, it's I don't even want to say this because it's hardly definitive, but I need to go back to this array of values and maybe add some more values so I can see what's going on. But just suffice it to say that it's not steering the way I think it should. But and then I'll also mention I'm changing the steering left and right settings from plus minus 0.73 to plus minus 0.96. And I'll talk a little bit about that here in a second. But on the board, I'll just repost this because I think it's buried in a reply to Bob somewhere. Oh, come on, why didn't you post? There it is. If you don't mind, Jeff, see if you can open that up. I thought I had it open. Come on, scroll out. A little too far. And so at the moment, I've got what I could describe as a logical diagram of how physical components are connected. And then over here, I've started basically a text box with some links to different, what I'll just loosely label documentation. So what I find really interesting, useful, is you can like put links in here. So this is just a link to, the actual board, and then this is a link to the actual code on GitHub. So if you can get a URL you can add a link to it, and this is just simply a box with some text in it. And the text I've chosen to put in it, oops, daisy, is the UDEV name, and this is a physical, I'm going to call it a sim link, but that's probably wrong. It's related to the physical place that board is connected in on this USB hub. So each one of these gets a unique number. The other thing I like about this, I've also, if you happen to open it up, I'd be curious if you can open up this link, which is just some notes in something called OneNote. It shows OneDrive, which is a Microsoft product, but I'd just be curious if you can open that up. I set the security so that anybody with the link should be able to view that, not edit it. The other thing you can do on these links, get that to go away, come on.
So
you can put a little,
on that note you just had, I can click on it and it pops up and says, oh, you have to sign in with Microsoft to view this. And I'm not going to sign in with Microsoft. So,
got it.
but it looks like it's, looks like it wants to let me in. So
The other thing you can do with these connectors is add a little bit of text. I think there's like 170 character limit, but you can add a little bit of text to this line. So not a ton of documentation, but for example, I can say, hey, I've got this. Oh, I put that on the wrong one. Should be here. So I send data to this USB to TTL connector, and then it's physically connected to this ESP32 board, and I can describe a little bit about what is on that interface, which I find useful. And then I just clip some pictures of the physical things that were connected and put them in here, again, just for reference. So I thought that was, helpful to be able to import a little photo for documentation. So yeah, I really like the this board, and there's some things I haven't really integrated in yet. And then on the documentation links, again, these are just going to be URLs to, I think most of them are, come on. Yeah, they're just another location on a GitHub repository, but like here's the launch file. Here's a, you may recall a spreadsheet that I put together that, actually I'm going to spend a little time talking about that. On vehicle dimensions and capturing them all in one place. So try to use that. Come over here and download here's the actual file, and you can download that. And then open that. So this is what I spent a little bit of time on, how to measure what the radians are from steering, straight to left and then to right. So what I did is put a compass on the wheel And sitting in my garage, the compass is at 183 degrees. I turn the wheel full left and the compass changed to 116 degrees. I captured the potentiometer setting on both of those and then did the same thing for right. I got those extremes, 67 degrees off straight and 57 degrees off of straight. So I told myself, well, to be consistent, I'm just going to do 55 degrees on both of them. Went back and captured the potentiometer settings for 55 or 96 or 0.96 radians. And so I've been making the tweaks to my program to use these values as the left and right extreme versus what I had before, which was probably had something close to these values, but I had 0.73 here in radians. So this is just a little bit more precise. So that looks like, how do I get back to my, do it over here maybe. I go to my code base for the main microcontroller, see if I can find those values quickly. So yeah. So then in these limits, which are used in the mapping code, you know, I've got these now set and ready to do some more testing to see if that if it's materially changed any of the steering when trying to run pure pursuit. So that's been interesting and something you knew a long time ago, and I've just sort of reconciled it in my head, is this pure pursuit. I had it in my head until, you know, a day or so ago that command velocity, angular Z, that's what you need, and that's the only game in town, when in actual fact in this pure pursuit program, you know, it calculates two steering related values, and one of them is angular Z, which is what I have been preconditioned to think that I needed, but that is a velocity variable. So this is not an angle. And Jeff is going to say, yeah, I knew that. This is a rotational speed value, where down here, the angle, you don't see a velocity statement in here, but it will use this delta max, which is the back to the configuration file set, which is the furthest left or the furthest right that it will turn. So anyway, now I've been passing. I have a program that reads command velocity angular Z and, you know, gets it over to this steering control motor, but I need to change that to use this steering angle instead of the rotational velocity, because I'm in actual fact set up to deal with steering angle, not rotational velocity, which these are my furthest left and right extremes. So that is
So a quick hack you could do on that, if you go back to that code you just had. And right there where it's calculating, it says that line you're on where it says command acre drive steering angle, and it's got that equation. You could just take that value and slam it right into your command velocity up above. So instead of outputting rotational velocity, you would be outputting the steering angle in a command you're already set up to handle, which is
I
what
like it.
that's what Teb Planner is doing. And put a note there
There's
saying
a
this is not,
deadline.
put a note that this is not correct, but you're doing it anyway.
Say that again about tab planning.
But that's what Teb Planner does. They just simply, if you set that thing saying car-like steering, they simply calculate an angle and overwrite the command velocity value. And they say right in things says, don't do this, but we're going to do it anyway.
Yeah, I like that idea.
So that'd be the quickest thing, is comment out those lines and just take the thing that says standard min arctangent, blah, 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 that creates an angle. And just up above where it's loading, says command velocity angular Z, just use that other equation to put it right into the angular Z, and that will give you something you can go ahead and read directly already.
Cool. The other thing I'll just touch on briefly. Let's see. Come on, Slack. I can't, then this is just a screen print, so I can't really move around, but this is the, I mentioned capturing and publishing a few variables to help debug. That's what this is those 9 variables. One of those, or a couple of those, are related to the LORA communication, and what you see when this green line is going to 0 is where the LORA is the quality indicator, which says, hey, do I have a good LORA message in the last second? Well, in those 7 instances, it said, no, I didn't. So it set the LORA safety flag to 0, which in the code, what happens is I, put my tractor in neutral when I don't have when this is not 1 or it's 0, the tractor is going to go to neutral, and that's because I don't want the tractor roaming around if I can't remotely set the e-stop. So it's a safety deal. So I'm not sure what's going on with the LORA thing. I don't know if it's because I got the LORA board integrated with the rest of the ESP32, or if it's some sort of interference around the house or what, but I've, in addition to controlling the steering, I've still got this LORA issue. Got a plan A and a plan B. Plan A, just for the interim, is to increase the 1 second threshold to, I don't know, 2 or 3 seconds, and see if that clears these out.
What's the
The
pink
other
line?
is to order. Go ahead, I'm sorry.
What's the pink line on that graph?
Data element 5.
Does it have nothing to do with what we're talking about?
Yeah, I think it does have something to do with LORA. Hold on, let me see if I can find it. I don't remember off the top of my head, but maybe I can find it here quickly. Bum, 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 bum. It had something to do with LORA, and I'm not remembering if it's no, I just don't. Come on, OneNote. maybe running a little slow. I'm getting the CPU message too. Oh, it's the hertz. How many messages am I getting? And so 2 is the most that I was historically getting, which meant, let's see, how do I get back to where I was? It's in Slack. So 2 hertz, it's getting, 2 messages a second, which is about as good as I've ever gotten, and then it drops to 0. So that's what the pink line is representing.
You don't know why it's doing that? Do you know on your transmitter, is it timing out, or there's various things that could be happening here?
Yeah, data element 6 is the RSSI strength. And so I thought that's at least one thing that I was tracking to see if I could figure it out. And RSSI is fine. I mean, minus 63 is like fantastic. It should be able to operate up to like minus 120. And that's just one data point, obviously, but if I pulled up Plot Juggler and plotted that, you'd see that our SSI doesn't appear to be the issue. So no, I don't know.
No,
And I tracked the number of loops that the processor is running, and it's not delayed. It's like 100,000 loops a second kind of thing. It's crazy fast. So my hypothesis, but it is just that, is something to do with it. Either interference around the house or something else at 915 megahertz, or I'm just trying to do too much with this ESP32 board, driving the OLED, running LORA, and the other computing load on there.
one thing you could do, because the stuff you pointed to before, I look like you're just looking at the time. Say, if I haven't got a message for 1 second, then you declare it to be a problem. But you don't seem to be printing out there the number you did get. One of the things I would do is go in there, and at the point it says I just had a problem, print the numbers out so as the thing runs. Is it actually 1001, or is it like 5,000 or something? Is it just right on the edge of not working, or is it something blatantly wrong? There's something blatantly wrong. You probably have something wrong in the code, or it's the way you're interpreting the radio stuff. If that makes sense.
Yeah, I mean, I'm trying to do a little bit of that with the hertz. How many messages am I getting per second? I mean, because if this were 3, it would show 3. If it were 1, it would show 1. But I'll have to think about, is there some other way to get more deep data about what's the...
You could plot the time when each message comes in, and that way you can tell how far between each one is it.
Yeah. I mean, that would show me actual, right? Yeah, that's a good idea.
Well, it would show you the time when they came in, which you're reading that milli function, and that should tell you in milliseconds when it received.
Mm-hmm.
And when it declares I got a message.
Yeah, the actual age of each message.
Yeah. So in between you can tell, are they showing up at a regular basis, or for some reason are they jumping around on you? And I guess I'm not sure on your, I didn't look at your code real hard to know, is it a direct back and forth handshake as you're doing this stuff, or does, is the receive on one, let's see, how do I want to put that? I assume you got a loop running that say so many times a second you say transmit data to one side, and then I thought you had like a state that after you transmit, you flip it to receive state and sit and wait for somebody to come back in. So I wasn't sure there um, how you're making sure that say the first one worked. I thought you had some kind of a timeout in there too. So, but there's various things to look at there as far as just sending the messages back and forth. Or something you just said. You said, well, you don't know if your OLED and all this other stuff's becoming a problem. If you just have if you either have a trimmed down version or trim this down to the point where it's just the radio running, and just send stuff back and forth and see how that acts, and look at the time between received packets and see how stable that is, and then take the code you got now and look at the time between received packets and see if it acts. If it's acting differently, then yes, maybe you got something else in your code that's taking up time so you don't get back to it or something.
Yeah, one of the things that I did when I was trying to increase the throughput on the LORA was just that, what's the fastest that I could get messages back and forth. And so this is the main loop, and effectively oh, come on, I wanted you to go to the actual function. I'm trying to set the state to either send or receive. And so, as soon as it's sent something, I want to change it to receive so that it's ready to do the next thing. That was the best that I could come up with. So there's not a ton of code here. But I like the idea of, capturing the actual amount of time spent on each message, seeing what that might show.
Are your messages always the same length, or are they variable length messages based on something?
Well, there's like 22, 29 bytes of data going to the tractor and 12 bytes of data coming back from the tractor. So there's only two, these structures. They're the same size, but, well, they're always sending the same amount of data and always receiving the same amount of data. But these happen to have two different data structures. So this was 29, and this was, I think, 12 or something.
Yeah, I guess the first thing I would do is, as I say, print out the time when you receive them, and the thing where you're comparing it to 1 second and it's failing, print out at that time so how far off is it? Is it off just a little bit, or is it off substantially? And that if it's off substantially, then you've probably got a code problem somewhere. And what was the other thing I was going to say? No, I forgot. Oh, then the other thing I do, yeah, if you look at it and sometimes it's coming up 1001 or 1010, yeah, just try increasing that time amount, take that 1500 milliseconds or something, and see if that fixes your problem. Because if you look at this, you said it ran for 15 minutes, and even when you look at that chart, it means it worked right about 900 times, and then it failed 7 times. So it's it's not a pervasive problem. It's just something randomly, something is happening to you. And I guess you don't know at this point whether it is something wrong with the radio communication or something in your code that's doing that. So maybe you print out enough more debug information about timing, maybe it'll give you an idea of what's happening there.
Yeah, that's definitely a good path to go down.
And that code you showed, you just said that was, transmitting and receiving. Is this actually part of your lawn tractor stuff, or is this just a test routine that was sending messages back and forth?
No, this is in the production version of the code running on the tractor.
Because if you have one kicking around that was just a test one that sends data back and forth, you could run the same thing there and figure out, how well the timing's working on that and see if that is a difference. Because if it works there and then doesn't work on your tractor, you got some extra things that are slowing it down, or for whatever reason you're missing stuff. So just as a standalone thing, if it works, that would give you a clue that yes, it does indeed work. It's just that once you put it on your tractor code, then there's something wrong there.
Yeah, it would, the thought of having something blocking it, 7 times out of 15 minutes, that's definitely something to consider.
And actually, that plot you had up, it kind of looked like it's happening at a regular basis. If you look at the green lines down there, they those look like they're all the same. It happening at some regular rate, and then it quits. It starts happening at that regular rate again. So that there's something. It looks like there's something funny going on there that so many times through that it complains. So. But that's just an observation that I made.
Mm-hmm. So that's where I'm at.
Another thing I wanted to mention on steering, just steering in general, something you might want to consider doing is adding a velocity component to your steering. So if you give it say you pick up a remote control and it's sitting there at 0, so you're pointed straight ahead, and you slam the joystick all the way to left or right, you're giving that a step function. It says, I want to go from center all the way out to here. And if you don't have anything in there that limits that, your thing's going to say, oh man, let me full power that motor. It's going to slam over there as fast as it can and probably right into the hard stops, because your your PID is probably going to oscillate back and forth. So when you get over to that side, it's going to say, oh, I'm getting close to the hard stop. And all of a sudden it's going to try to drive it right past the hard stop, I think, the way the PID code works. So one thing you could do there. Oh, my screen quit for a second. Okay, it's back. One thing you could do is put a velocity on that. So if you give it a step function, then each time through the loop, you say coming in from the outside world with the joystick or from ROS, it says this is the requested steering angle. And then in your code, you got your main loop running, and there's say if target angle is less than let's see which way we go. It says target angle is less than requested angle, then you either want to add or subtract some small value to that. And then each time you go through the loop, instead of giving a let me whip up something here. So basically, this is going to show up. So basically, you give it a step function like that, and then by putting this extra code in your loop, then it's gonna move your target angle that your PID is trying to follow. And this is backwards here. So anyway, you can control the slope of that, and you can slow it down so it's not going to be trying to move at full speed to get out to the to the location you give it. And now if you're given, so each point in here is a point in the loop as it goes through. If you're now controlling, instead of going, you're steering, say you're centered, and you go whammo, you go out all the way to hard stop. Instead of doing that, you go click, 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 click. So you're controlling how fast that moves out there. And now, since instead of going, the full distance here, now you just got a little distance here. You're controlling to each time. So now you can control you can turn up the power on your PID also, because you're not trying to go, you're not trying to go the full distance. You're trying to go just a smaller distance as you go. So basically, just in your code, each time you say read the requested angle from ROS or the joystick, then just say, have make a new variable called target angle, and you just track that. So that's going to track the the requested stuff coming in. And then you say, so each time you say either add or subtract the value until they're equal, and you say, so you add it and say, well, if you're greater than that, just clip it to whatever the incoming value is. So it basically all you're doing is slowing it down so it can't jump the full distance at one time. And by running that, the value you add to it each time by controlling that, you can either make it turn very slowly, or if you put in a value, I forgot what your current value was. Last night you were saying 48 degrees. Well, if you put in a value, an increment of 50 degrees, then it's going to do the actual step function. It's going to follow exactly what you tell it. Or you can put in a very small number like 1 or 0.1 or whatever, and it's going to take longer for it to move out there. So that might just give you better control over your steering.
Yeah, at the moment, I mean, the PID takes the actual steering in, and I've just limited, could go up to 100 or could go to 255. I've got it limited to like 150. And so there's a clamp there. I think what you're saying is, make the power limit variable.
Well, no, I'm saying where up there where it says steering actual angle, is that do steering effort float steering actual?
That's going to vary it between now 0.96 and negative 0.96.
So I'm saying where your value comes in from the outside world. So if somehow you're going to read that up.
Here's the potentiometer. It reads the actual potentiometer and then maps that to.
But that's not what I'm talking about. I mean, way before that. I mean, as soon as you get your value from either your joystick or from ROS, at that point is where you want to limit how fast that can change on you. So you want this code to stay the same. You want it to follow the requested target position, but you just want to move your target position at a much slower rate than whatever's coming in from the outside world. So right now you've got something in your code that says, I just received a command velocity with an angle, and you're saying take that angle and feed it in the PID and slam it over to that point. And I'm saying instead of doing that, take the incoming thing and say create the new variable called target angle, and just slowly increment that each time through your loop, and that'll just slow down the steering. So it's not trying to go from one point all the way to the other point at full power.
Yeah, the language is just, so this input for the steer set point is what comes in from, as of today, command velocity angular Z. So this is just my simple PID that says how far off am I between what command velocity angular Z is saying and.
So you want to modify the value at steer set point. You don't want to just take it from ROS and put it into steer set point. That's where you want to put the stuff in between that's slowly incrementing or decrementing that number, and that will control your target position. So rather than looking into the PID stuff, it's just a matter of telling it. Consider this: if you pick up your joystick and you got the thing on the ground and driving forward, if you just slowly move your joystick right or left, your steering is going to follow that. Now, if you take it and slam it all the way to the right, your PID is going to go, whoa, let's give it full power. It's going to slam over against the hard stop. So what you can do is you can just artificially in the code, you can limit that as to how fast that can change. So when you say take the value from command velocity, instead of loading that directly into steer set point, you would say if steer set point is less than the angle I just got, then we want to subtract the small value from it. Or if the number is greater, then we want to add a value to it. So you leave the rest of the stuff alone. It's just like if you're running from a joystick and you're just slowly moving the joystick left and right, then your steering's going to be moving much slower. But if you slam the joystick all the way to the right, you're giving it a step function and it's going to give it full power and it's going to try to turn it as fast as it can to get over there. So I'm just saying slow down that requested position.
Yeah, I see your point.
And then also at one point I was trying to convince you that if you read up the value from your pot and say if you're beyond a certain point, just kill power to the motor. So if it's trying to drive into the hard stop, say going left, if you read up directly off the pot and say if we're at or beyond the point we gave it, then simply substitute your PWM instead of the value you're supposed to be giving it, just load a 0 in there, and that basically just kills power to the motor. So it can't. It still might bang into the hard stop, but the motor's going to be turned off when it's doing that. And then also it's going to do that less if you slow down the steering, like I was just talking about. But I thought at one point you had added that code in there to do that. The code didn't look like the way I would have done it, but I dug through it and yeah, it looks like it would have worked, whatever you had there. And I don't know if you still got that in there or not. So basically when it comes down to the point, you're just ready to create the PWM to send out to the motor. That's the point you want to check to see, just go out and say, where am I right now? And if I'm too far, don't pass the power on, just pass 0 instead. So it'll just kill power to the motor in that direction.
Yeah, I used to have some sort of clamp on the actual pot coming in, and it looks like I removed that somewhere along the way.
So
This
you're talking about your code somewhere you say do PID or whatever, and that's going to return this value back to you. That's going to be some power value. That before you pass that power value on to your PWM generator, that's where you want to check it. Check your steering and see if you're too far one way or the other, then don't just pass that number through. Just pass a 0 instead. Maybe down here where it says that
yeah,
you're doing.
just to clarify, with these Citron motors, you've got, I mean, when you say power, I'm thinking you mean literally power, because you can control the power, which is different than the error, calculated by the PID. I mean, the PID doesn't control whatsoever the power going to the motor.
It should.
I arbitrarily set the power at 150. This is the steer effort comes back from the PID,
Okay.
and that's what gets written to the motor controller. And then this is just a clamp on the steer effort to say don't go over the power limit.
Okay, so you're just saying you're just limiting the PWM that's going to go out is what you're doing,
Yes.
which translates directly into power. Okay.
Yes.
Okay.
But the steer effort, well, I mean, it's never going to be greater than 150 because that's what the power limit is set at. Because like you said, I don't want all 12 volts being jammed into the steer motor. So anyway, that's the only clamp I've got at the moment.
So then when you come up with steer effort, what do you do with that?
If it's within the power limit, it's going to go straight in. It's going to be it's going to be sent to the PWM pin on the Citron motor controller.
So that's the point right there where you want to say just before right inside of this function, you can go out and say, read your pot and say, am I beyond my artificial limit that I supplied in that direction? Because you have to say, am I trying to go right or trying to go left? If you're trying to go left, then it says compare it against the left value that you put in there. And if it's beyond that, then just blatantly, instead of putting steer effort out, put out a 0, and that'll kill power to the motor. So if the thing is going towards the hard stop like this and passes this point, then the motor, it just kills power to the motor, so it can't go any farther. But if you got the thing in there, it says if you're going left or right, then if you move it, then it can still back out of that. And at one point you had implemented that. And I don't remember where we talked about that, but I think we discussed this on one of the meetings, and then you actually put some code in to do that. But that will, because the other, here, let me whip up another drawing here. So if we give it like this, and the steering goes like this, because what's going to happen is, here, can you stop sharing for a moment here?
I'm pressing the button, but something else must, there we go.
And let me make this bigger for everybody, for the home audience. So on this case, if you give it a step function, the motor is going to start ramping towards the destination, and the PID is going to let it go right past. It's going to oscillate. It's going to go past. So if that happens to be set at your hard stop, you're going to slam into the hard stop, and your motor is still going to be given full power to keep going, and you can't do that. It's going to break something. So if you basically check it against, let me put another artificial limit in here. And if we look at, let's see, it's going to be like that. It's going to do something like this, where you set your arbitrary limit, that dotted line there, and as the motor gets close to that line, you just simply, here's the PWM, whatever PWM you're putting out, just set it to 0, and that kills power to the motor. So you might have enough momentum that the motor is going to keep going and hit the hard stop anyway. But at this point, you've killed the power going to the motor. So the motor, the motor is just coasting at this point. So basically, hopefully what you want it to do is, it'd be nice if I had a different color pen here. Now, let's see. So essentially the position of the motor as it comes up here, and you kill the power to it, then hopefully it's not going to go far enough. It's going to pass. Say if that's your hard stop right there, it's not going to slam into the hard stop because it'll slow down. Now the other thing is, if you add this thing with the controlling the velocity of the steering that we were talking about just earlier, that it number one, if you're moving it slower to start with, instead of letting it run at full power and full speed towards the hard stop, you got a better chance of getting it under control and slowing it down. And the other thing I thought about on that was you could actually put a variable velocity. So if you're in the center, you give it, full velocity, let it go as fast as it wants. The further you get out towards the edge, start slowing down the velocity of it. So as you're getting closer to the hard stop, you're going slower anyway. So that's just another thing that could be played with in order to make that behave a little better.
Yeah, the steering would be probably amazingly responsive. If there was a wide gap between actual and target, give it all 12 volts. But then
and you don't have to ever give full power if you don't want to. You've got that limit on there. But I'm just saying you might be able to raise that limit if you're not running it.
If I have some sort of protection to keep it from slamming into the endpoints.
Yeah, if you basically just slow it down and get better control over it, then I think would probably be happier with it. And you could leave it just, leave that same power level there you got right now. It's just that you're just simply slowing down the target point, so it just doesn't steer as fast when you tell it to do something. And you could play with that, because you get it too slow, that it's not going to react. The planner is going to be saying, well, turn to the left, and if it doesn't turn fast enough, then it's going to get confused and start oscillating back and forth. So once you get at that point, you can play with those numbers and make it faster or slower to compensate for that. And of course, right now, if you don't have any of that stuff in there, then what you simply have to say, here's your hard stop over here. You have to just move the point, your artificial point way back here to make sure that it doesn't overshoot and slam into that. So, but if you get it, so the thing is moving slower and you got these other protections there, you can move this out closer to your hard stop and just get a wider steering angle without, hopefully without destroying anything.
Yeah, the limited protections I have at the moment would be, not giving it full power. And then, I've got on the full left, there's, based on my rough calculations, about 12 degrees of freedom between that pot setting and what I'm actually putting in as the limit. And then on the right turn, I've just got a couple of less amount of space. So I got the power setting set at 150, which is 3/4 power, and then I've got a little bit of protection using 55 degrees instead of the full.
But I'm talking about two different things here. There you're saying you're going to limit back at the at ROS what angles this can go to. What you really need to do is on your vehicle has to know, do not go beyond this point. That's why, as I say, after you've done all your calculations and figure out the power value, just before you output your PWM, then check your position. And if it goes too far, kill the motor at that point. What if you rely on going up to the point where you're trying to limit actual angles coming in, I don't think that's going to do it for you at that point. Because they say once you pass it into the PID, it's gonna try to oscillate back and forth like that. And when it does, it's gonna go further than you want it to. So that's why you need to put a check on, regardless of anything else you're doing, put a check right at the very bottom that says you want to go to apply the PWM, see where my position is, and if I'm beyond my set point, which is going to be, it could be different than any other set points you have for angles or anything. It just simply says if you get to that set point, don't let the motor go any farther. Just kill power the motor in that direction.
Yeah, that's a good safety check.
Now the other point is you've got this dividing line between ROS and your vehicle, and the vehicle has physical limits on how far it can turn and how fast it can go, and what you expose to the outside world. That is being put out, and from the outside world, with a joystick or a planner, and you say go to 90 degrees to the right, and you can't do that. Well, your vehicle has to be limiting that. So yes, as you were saying, you're looking at the angles down on your vehicle, you can say these are the acceptable angles that I can take. So if you've got, I saw a 55 degrees and 67 degrees, whatever you pick on there, you can limit it to those inside of the vehicle. But then this thing at the bottom with a PWM is protecting you against the PID doing something stupid, basically, is what that is. So at the top level, let's say for the sake of argument, let's pick a number. You had a 55 there. Let's say you can go to 55 degrees either direction. Well, if the planner puts out 60 degrees or 70 degrees, the vehicle will just simply ignore that. You want to have something in there that, as I say, down in the vehicle, you can clip the incoming stuff and say, these are my limits that I'm going to accept. So you can clip it at that point and then back up on your planner. If it's putting out bigger than what you want, that's okay, because in the vehicle, you'll clip that and not let it go beyond that. And if for some reason on the vehicle, you're doing less than that, maybe it's going plus or minus 50 instead of the 55, it'll still run. It's just, it won't turn quite as sharply, and everybody should still be happy on that. And that last week I was talking about my joystick, and that was the concept that came up with there. I thought I'll just blatantly scale my joystick to plus or minus 30 degrees, even though I think my vehicle will do like plus or minus 28.6 degrees. So that's actually a bigger number, but it'll just get clipped down there and just won't go beyond. Mine's slightly different because I have an RC servo instead of the home brew PID, but still it's the same concept that, the joystick, if it puts out too great a value, as you move the joystick over like this, it'll get to a point where the wheels will just stop turning, but you still have a little more range on the pot because I'm putting out too big a value. But nobody cares because the vehicle knows it can't go that far and that should work. And if for some reason I got too small a value, let's see how can I say that? Basically, I put the joystick all the way to the end, but it's too small a value. Then maybe I can only turn 25 degrees or something, just because the joystick's not putting out enough value. But at least on the joystick, I don't really care. I'm just trying to drive the thing around, and I'm not trying to do anything precise. And once you go to the ROS planners, they expect that if I tell you to go at 23 degrees, it expects you to go at 23 degrees. And joystick, I don't really care. And then on the planners, if you got too big a number in there, it's going to say, okay, go to some big value, but your vehicle is just going to clip it off and not let you do that. So between ROS and your vehicle, you got this agreement between the two, and the on the vehicle itself. So you want to clip anything coming into what you know is valid, but then above everything else, down at the very lowest level, put in your thing that says, before you do the PWM, verify we're not past whatever arbitrary limit you've set for that. And then that should be close to what you want. And then on top of that, if you put the velocity in for the steering, then that should give you better control over everything anyway, because you're not letting it bang back and forth wildly. You're setting how fast it can move at that point. And then the PID is honoring that, because your angle that you're giving it, you see right now, right here, if I give it a big angle like that, it's gonna apply full power, whatever up to your limit that you have. It's going to apply all that power to try to get over here as fast as it can, and then it's going to oscillate and bang back and forth. But if you put that thing in between to control the velocity, then you give it, all the way over the hard stop, and you go tick 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 tick, and you can control how fast that goes by just changing that increment number up or down to control that. It's just, if it's too slow, then the planner is going to get antsy and say, oh, you're not doing it fast enough, and it might start putting some other weird numbers out. But again, you can play with the steering speed versus whatever values you have on your parameters for your, like in this case, the pure pursuit. So in pure pursuit, yeah, you want to tell it a number that's going to give you close to what you want. And if it's too big, let the vehicle clip it. If it's too small, it just won't get there. But that way it shouldn't destroy anything. It should be drivable. And I'm not sure how touchy that pure pursuit's going to be, because I've been too lazy to actually load up and try it on mine. So I don't know what all the implications are there. I know you pointed out if you give it a velocity of 0, it starts doing something weird and hunting back and forth on the speed. And I didn't realize it would do that either, because again, I've been too lazy to try it. So you'll probably run into other things there. But and back to this concept about controlling the velocity of your steering. If you look at the actual Ackerman command for the steering part, it says, here's my steering angle. Then it says, here's my steering velocity. And I think they also have a steering acceleration. And I thought about that briefly, and I couldn't decide what acceleration you want to do there. But they got fields in the Ackerman commands to do that. So theoretically, you could pass it that value down with the Ackerman command and say, this is the velocity I want you to use while you're doing the steering, or just go in your code and hard code it in there. That'd be the quickest way, and then you're in direct control of it at that point. But if you put it in the Ackerman command, that means, say, running on pure pursuit, either pure pursuit could control that, but I don't think it does. So that you would probably just put a hard coded value there. But if you go to a different planner and you wanted to the velocity to be different, then you could just put it in that command and pass it through. So
have you noticed if this pure pursuit thing that we're trying to use calculates any of that?
Well, right there, if that we're saying command acker.drive, there's also one that's going to be or drive, then it says steering angle, and then it says speed is loading in V. It's probably just using whatever the defaults are. It's probably putting zeros in the extra fields. There's like a total of 6 fields in most people don't do anything with those because their vehicle is not going to respond anyway. But I don't think it's calculated in that.
Yeah, that V underscore is the max linear speed.
And I just briefly looked at that. It doesn't look like Pure Pursuit is actually changing that. It just takes whatever speed you told it. I think it just gets passed through all the time, but maybe I'm wrong on that.
I do see this jerk. We'll see what that means here in a second.
Jerk is the change of acceleration is what jerk is.
Linear acceleration.
And that, so the jerk is probably for your forward velocity, and acceleration is probably for your forward velocity. Whereas steering has other things on it, but I don't know. They probably just load those in with some values to just pass through. So 100.0 just means I think it means ignore those fields. So if you have a vehicle that's actually doing something with that, it would just ignore those.
Yeah, it's not clear to me what.
But I'd say for the moment, just ignore the whole Ackerman command stuff. Just go into your code and say, if you set the something to control your steering velocity, just hard code something in there to, just change your numbers up or down to get it to a reasonable speed, and then just not worry about the incoming message. That's the way I would approach it, at least to start with. I thought as you scroll by, I thought I saw something that said steering velocity. The probably steering underbar velocity. I don't remember where that was, but so they might actually be doing something with it. I don't know. And it could even be they've got something in their code to limit how fast the steering will move, but that's something else you'd have to, track that down and see. But just by putting it in your code, you can put it in and just ignore it by putting in a very fast increment number, and then basically it'll just follow whatever comes in. So if Pure Pursuit is already controlling the steering velocity, then you can just tell the vehicle, take whatever comes in, and it should still work either way.
Yeah, this says angular velocity, but it's really rotation. I mean, that's what this is effectively calculating. And this is just an angle. And this is linear velocity.
But that's something you just experiment with it and see what it does, and decide if you need to do anything beyond that.
Okay, young man. Hopefully next week you'll be super high def with your fiber optic connection.
Well, hopefully.